Good morning, friends. In class 2, we are going to start exercise number 1. First exercise, economic load dispatch. The basic concept of economic load dispatch is the total demand of the system is economically generated among various generating stations. Consider this a power system which consists of n number of generating stations. The load is represented as a PD. Economic load dispatch is nothing but generating power economically to meet out this load. Consider this P2 as very low generating cost, then the total generation, among the total generation, P2 will contribute more power. This is called economic load dispatch. The total cost of generation is normally represented by the quadratic form of cost equation alpha I plus beta I Pi plus gamma I Pi square. In other words, A Pg I square plus Bi Pi plus Ci. This is the cost curve with respect to total power generation. When we take the first integration of cost curve equation, we will get this one dci by dpi equal to 2 lambda I Pi plus beta I. So when we draw this incremental fuel cost curve with respect to Pi, we'll get this value, this curve. Normally, economic load dispatch is a minimization optimization problem. That means total cost of generation should be minimum by considering this constraint. Total generation should be equal to total demand. So it may be a minimization of Ft equal to sigma function of Pgi, that is Ci. This optimization problem is solved using Lagrangian multiplier method. So Lagrangian multiplier method is nothing but L is equal to objective function plus lambda into operating constraint. So we convert this objective function and constraint into Lagrangian equation like this. In order to get the minimum value, we have to satisfy these two sufficient conditions. First one is lambda dou L by dou Pi equal to 0, dou L by dou lambda is equal to 0. By considering this equation, we will get this equation. So we take first derivative of this one, dou Ci by dou Pi is equal to lambda. So that means incremental fuel cost of all generating stations should be equal to get the minimum operating cost. That is from first sufficient condition. When we solve second sufficient condition, we will get this one. Total generation should be equal to demand. When we substitute this condition and this condition in this Lagrangian multiplier, we will get this equation lambda is equal to PD plus summation of beta I divided by 2 lambda I divided by summation of 1 divided by 2 lambda I. This economic load dispatch can be solved using three different methods. One is analytical method, another one is graphical method, last one is iterative technique method using gradient method. By using analytical method, we can directly get the value using this equation. We can directly get lambda value so that we can get each generation as well as total cost of the system. Graphical demonstration is nothing but we have to draw cost curve so that we will get the lambda common value. From this value we can get individual generation and cost, total cost. Iterative technique is nothing but we have to assume suitable lambda value initially, then we will get individual generation, then we have to find the deviation from the demand with respect to total generation. That based on this deviation we can increase or decrease the small value of lambda. that will give the new value of lambda. So using these two equations iteratively, that exact answer will be calculated using this gradient method. This is a typical example